Welcome to part 2 of the Microservices mini-series. This was originally supposed to be a part of the previous video, so we'll dispense with the introduction and just get started. We want to work on our own project, but unlike with the Azure web app, using the microservice architecture is not as simple as uploading the project online, so we want to take the time to properly familiarize ourselves on simpler projects first. We don't want to be burdened with concerning ourselves how we will fit our old one into the new framework. Here we've started an Azure Functions project in Writer. In Visual Studio and VS Code, the setup should be similar as all these project setups are based off a template. If you look around, you should be able to find a way to create it using the command line. VS Code might not have inbuilt support for these kinds of templates, but it does have an Azure Functions extension, which has a Create Project feature. We are using a project with a default worker here. There is also the isolated one as well. We'll go with the default one for now. If you create an F# version of the project, create a HTTP trigger for it and try to run it, you are going to run into a very perplexing error. It is actually pretty shocking that the starter Azure Functions project template for F# would be wrong and in need of modification to work, but that's what we need to do in order to copy the host's JSON file to the output folder correctly. Once the modifications are done, the project should run and you'll be greeted with a reply to this Hello World equivalent for Azure Functions. If we pass it the name in a query string, it will change the response. Let's try making the isolated worker project next. We'll terminate the session for the old one, rename it to default, and create the new one. This will present us with a setup that should be more familiar to those used to regular ASP.NET Core programs. We'll copy the hello.fs file and see a bunch of missing packages in it. In the background, what we've done is create a C# project, and in it, we can see what we are missing. We'll take it, copy it into our F# project file, and reload it. If we do that and wait a bit, what is going to happen is that none of the errors will go away at all. Instead of being weird about it, let's just do the simplest thing possible and add the necessary packages from NuGet. The reason why we didn't need to do this in the default worker project is that the SDK is different from the one in the isolated worker project and comes with a lot of extra stuff. We'll add the others as well. It is really great how NuGet packages are all named after their namespaces. We'll start with the biggest one as it will pull in the sub-dependencies. It seems the package we added pulled in everything else we needed. Let's try running this. And unfortunately, it is a failure. In the terminal, as you can see, it is asking us to pass in the language. Where exactly? And how should we pass in F#? Let's try one more thing. We'll start a C# project and use it as a template. Wow, what a shit show. Being able to deal with situations like these is why web devs get paid the big bucks. We didn't expect that the C# project would fail to run for whatever reason. Well, the reason is obvious. It is missing the local host in the URL, but we have no idea what to do about that. We are going to change our approach. Forget this Writer project, we'll get back to it later. What we will do instead is try following this compositional IT article. Our first problem is that the Azure Functional Tools install command is wrong, but after a quick search, we found the correct package. We already have the VS Code and the .NET SDK, so we'll skip installing those. Now that the command line tools have been installed, next we'll have to install the relevant VS Code extensions. We'll do that from the editor itself. We already have Ionide, and we installed the project templates yesterday, so let's go into a short time lapse while we get the extensions. Sorry, we can't get this project to load with Ionide even after upgrading to pre-release and several restarts. We'll have to go back to using Writer. We'll try to follow the article as much as we can otherwise. As our first move, let's try copying that single SDK package into our other project and replacing those packages that we've added. We had a hunch there should have been a better way than the way we did it, and this is undoubtedly it. Replacing the packages worked, but we are still getting the URL parsing error. Let's leave that aside for now and switch to the newer project. Thankfully, it works. We are surprised we didn't need that startup file, and that the project is now acting more like the default worker one, but never mind that for now. What is next in the article? Every time we run the project in Writer, it complains that Azurite is not configured, so probably that is the main reason behind our troubles here. And this article corroborates that hypothesis. In VS Code, we did in fact have those buttons to start the various kinds of storage. We'll pause here for a bit and see how Azurite could be configured in Writer. We're back. We'll start off by installing the Azure package for Node and then see where that leads us. Azurite should be configured and running in the background, but the program is still giving us the same error. We need another pause to think why this is happening. We are sure that Azure is running, otherwise clicking on the storage emulator in the Azure Explorer would show us errors, but otherwise we don't know what else we could try. We figured it out. It turns out in the project the setting here needs to be changed, and the article forgot to mention it. This covers how to set up the default worker. Check out what the functions worker runtime says here. In addition to this one, there is also the isolated version. We really need to figure out how to set up the isolated workers as well. What we've done so far hasn't gotten us any closer to that. Since the F# materials are so sparse, we'll focus on setting it up in C# first and then try to use that understanding to make it work in F#. We figured out how to make the C# project work. We got rid of the old configuration, which we regret as we can't showcase it anymore, but if we look at all the configurations in the editor, we'll see a bunch of different ones. The one we were using to run the C# project was weird and didn't have a local host in the URL for some reason. Let's try running this one to see what happens. This time the project should run properly. We wish running .NET projects wasn't such a complicated affair, but this takes care of the C# project. And with this knowledge, let us see if we can deal with the F# project as well. In the F# project, we know that we messed with the packages, so let us paste the C# ones inside. Hopefully that will alright everything. We'll also get rid of that hello.fs file. Our goal right now is just to run the base project. And for some reason, despite having the relevant packages, we still see a lot of red. We'll try making a new project, but first let us try changing the version number to .NET 7. We have no idea why F# is glued to the old SDK. Cleaning up the project and then reloading it did the trick. We are glad to have that out of the way. Next, let's try translating the hello example from C# to F#. We've managed to calm down somewhat. We want to demonstrate that reloading the project straightforwardly does not work in Writer. Right now observe that it sees the HTTP trigger. If we go into the project file using F4 and comment out all the relevant packages and then reload the project, nothing happens. We can even try to build it, and it will finish successfully. Pretty crazy, right? Next, so we never forget this lesson, let us try cleaning up the project and then reloading it in the IDE. Nothing happens. But if finally we do a .NET restore, that is when it realizes the package file has changed. We also need to do a reload in addition to the restore. We'll play with this for a bit just so we know what is going on. As you can see, if we leave the HTTP package commented out, restore and then reload, we get the same error as before. Then if we comment it in, then restore and reload, everything starts working again. We thought that simply reloading the project in the IDE should be enough for it to respond to all changes in the project file, but we were wrong. So learn from our experience. A stupid person learns from his own mistakes, while a smart person learns from the mistakes of others. At this point, we've made every mistake that one person could possibly make when starting a new function app project. We've bluttered the configuration, we messed up the packages, we've been programming since 9 a.m. and we've still yet to get the second Hello World program to run. Amazing! But that's configurations for you. You'd think that programming is the hard part, but no, it is configuring the project. The previous miniseries was exceptional because getting authentication to work was all about getting a grasp on how it should be configured. So as a result, it took 3 weeks. At the end of our last video, we had a hunch it would be like this, and wisely decided to get smashed on Hello World templates instead of anything serious. Our sense now is that we have a grip on this. Whoops, back when we removed the semicolons, we removed one inside a string and that caused havoc here. Easy fix. Great, now everything works as it should. Let's end the video here. We don't want to stretch this one over multiple days. We'll start fresh tomorrow. Please like and subscribe. Now that we've done the initial ice-breaking, we are now well prepared to dive deeper into the subject of serverless computing. In the next video, we'll translate the other examples to the isolated worker and even figure out what the difference between the isolated and the default one is, and why Azure functions are on their 4th version. We'll be back after a break.